Hello children, hope you are doing well. Myself Shachi from Crack Chemistry. Today I am here with the class 11 topic. The name of the topic is Pauli's exclusion principle. This topic is included in chapter 2nd of our NCERT textbook Chemistry Part 1. The name of the chapter is Structure of Atom. So this topic is very important for students of class 10, 11, 12 and for those students who are preparing for their competitive exams, as it helps us in writing the electronic configuration of atoms, and which is very important in each and every aspect of chemistry. So let's see what we are going to study today. But before starting the topic, I request you to please subscribe my channel, like this video and share the link of this video with your friends. So let's see what we are going to study today. So today we will study the class 11 topic. The name of the topic is Pauli's exclusion principle. So first of all, we will see what is Pauli's contribution, what Pauli did. So Pauli's exclusion principle, it imposes certain restrictions to the values of all the four quantum numbers of electron in an atom. So what does Pauli's exclusion principle explain? Pauli's exclusion principle imposes certain restrictions to the number of electrons in an atom. So we can write here, it imposes some restrictions. Restrictions to what? It imposes some restrictions to the number of electrons in an atom, to the number of electrons in an orbital. So this is the Pauli's exclusion principle. What does it explain? It explains, it puts some restrictions to the number of electrons in an orbital. So we will discuss this Pauli's exclusion principle in detail. As I told you, the number of electrons which can be filled in various orbitals are restricted by this principle, and this principle was given by the Austrian scientist. His name was Wolfgang Pauli. So what is this principle? According to this principle, no two electrons in an atom can have the same set of whole quantum numbers. So according to this principle, no two electrons in an atom can have the same set of four quantum numbers. You already know that. I have explained in my previous videos. If you want, you can refer my previous video. The name of the video was quantum number. So according to this principle, no two electrons in an atom can have the same set of four quantum numbers. So I want to explain this Pauli's exclusion principle by taking the example of lithium atom. Children, lithium atom is having atomic number 3. So what will be its electronic configuration? Electronic configuration, how can be written? This already I have uploaded in my previous video, filling of orbitals. You can refer that video also. So atomic number of lithium atom is 3. Its electronic configuration can be written as 1s2, 2s1. So now I am going to explain Pauli's exclusion principle by taking the example of lithium. I am talking about the two electrons which are present in 1s subshell. So the two electrons which are present in the 1s subshell, I am writing the electronic configuration again here so that it will be easy for you to say lithium 1s2, 2s1. So from this electronic configuration, it is clear to you that lithium consists of two electrons in the 1s subshell. So I am talking about the first electron of 1s subshell. I am talking about the first electron of 1s subshell. So what will be the value of N for this first electron of the 1s subshell? I can write the value here. What will be the value of N, children? Already you might be knowing that N is the principal quantum number. It represents the main shell in which electron is present. So you can see here the first electron which I am talking about, the first electron is present in the first shell. Here 1 represents this. 1 represents the main shell in which electron is present. So n, the value of n for first electron is 1 because it is present in first shell. Now, what will be the value of n? So in bracket I am writing here n represents the shell. It represents the main shell in which electron is present. Now I am writing about the second quantum number. Second quantum number is the azimuthal quantum number, and the azimuthal quantum number represents the subshell in which electron is present. So you know that values of azimuthal quantum number depends on the value of n, and the values starts from 0 to n minus 1. So the values of L will be equal to values of n only, but the values will start from 0 and will end at n minus 1. So as n is 1, L will also be only 1. So what will be that only one value of L? That value will be 0. And always remember that L represents the subshell. And here if the value of L is 0, it means S subshell. So what we can see here, in the case of first electron of which was present in 1s subshell, the value of n is 1, the value of L is 0. So now I'm coming to the third quantum number. The third quantum number is ml, which is the magnetic quantum number. The magnetic quantum number represents the number of orbitals which are present in the subshell. So children, here let me write subshell because n represents shell, L represents subshell, and what does ml represents? ml represents number of orbitals present in a subshell. So children, always remember the value of ml depends on the value of L, and it can have the maximum values equal to 2L plus 1. Everything I have uploaded in my previous videos. So if we write the values of, forgetting the values of ml, I told that the values of ml depends on the value of L, and the maximum values will be equal to 2 into L plus 1. So if I put the values in this formula, we will get 2 into 0 plus 1. So the ml will also have the value, only one value it will have, and that value will also be 0. So I am not explaining everything for quantum number because already I have uploaded in my previous video. So that ml is equal to 0 is one value only. So it represents that if S subshell, in case of S subshell we have only one orbital. In case of S subshell we have only one orbital. Children, I hope you are understanding this point. Till now we have discussed about we have studied about the three quantum numbers. We are talking about the first electron of the lithium which was present in the 1s subshell. So n is equal to 1, L is equal to 0, ml is equal to 0. Then I am talking about the last quantum number, that is the spin quantum number. Suppose it is having the value plus half, means a spin up and a spin down. So now I will discuss about the second quantum number. On the right side only I'd like to discuss about the second electron here, which is present in the 1s subshell only. So for the second electron, again, as it is present in the 1s subshell, so value of n will be 1 for second electron. I'm just writing here for second electron. So this I'm talking about for second electron. Second electron, it is also present in first shell, so n is equal to 1. And as I told you, the L will be also 1 because values of L depends on the value of n, and it may have the values n minus 1. So L is also one value, and what is that value? 0. Similarly, ml, I'm talking about ml, will also be 0 in this case, but the ms, which represents the spin, which is a spin quantum number, which represents the electron spin, in this case it was plus half, means spin up. Here it will be the minus half. So now we can conclude that according to Pauli's exclusion principle, two electrons in an atom can never have the same set of all the four quantum numbers. They may have the three quantum numbers equal, but they must differ in the fourth quantum number. They must differ in a spin. So the same statement is written here. It can be Pauli's exclusion principle can also be stated as only two electrons may exist in the same orbital, and these electrons must have opposite spin. What does this principle states? Only two electrons may exist in the same orbital, and these orbitals must have a positive spin. So again, I just want to write the example of lithium. I'll write the configuration of lithium like this. So this is the 1s subshell of lithium. Here I am showing the electrons with a positive spin. One is having the spin up, one is having the spin down. This is the 2s subshell. So you can see here we have discussed about the first shell as electrons which are present, first electron, and we have discussed about the second electrons also. Both the electrons were present in the first 1s subshell only. They had all the three quantum numbers identical, but the only difference was in the value of their spin quantum number. So I hope this point is clear to you. Children, now I want to discuss about the effect of the Pauli's exclusion principle. What will be its effect? The restrictions imposed by Pauli's exclusion principle on the number of electrons in an orbital. I'm just repeating my sentence that the restrictions imposed by Pauli's exclusion principle on the number of electrons in an orbitals help us in calculating the capacity of electron to be present in any subshell. As you can see that just now we have studied that according to Pauli's exclusion principle, an orbital can accommodate only two electrons, because the two electrons which are present in an orbital will have the same set of all the three quantum numbers, but the spin will be different. So it means that an orbital cannot accommodate more than two electrons. So now this restriction which was imposed by Pauli help us in deciding the maximum number of electrons which can be accommodated in any subshell. So for this I want to take an example. For example, all of you know that, for example, S subshell comprises of only one orbital. S subshell has only one orbital. S subshell has only one orbital. So now, what do you think? How many electrons can be accommodated in S subshell? S subshell, as it has only one orbital, so it can accommodate only two electrons. Can accommodate. And these points are very important for you to remember. Can accommodate only two electrons because the S subshell consists of only one orbital. Now, similarly, I would like to move to the next subshell. I'm just coming to discuss the P subshell here. Children, P subshell, as you know that P subshell consists of three orbitals. P subshell has three orbitals. And as you know that each orbital can accommodate two electrons. So how many electrons can be accommodated in the P subshell? P subshell can accommodate 6 electrons. P subshell can accommodate 6 electrons. So I hope this point is also clear to you. P subshell can accommodate only 6 electrons because the P subshell is made up of 3 orbitals and each orbital can accommodate only 2 electrons. So that's why P subshell also can accommodate 6 electrons. So P subshell can accommodate 6 electrons. Now I would like to discuss about the D subshell. As you know that D subshell has 5 orbitals. D subshell has 5 orbitals and each orbital can accommodate 2 electrons. So therefore D subshell can accommodate 10 electrons. D subshell can accommodate 10 electrons. So these are very important points which you must remember while writing the electronic configuration. While explaining many questions, we need to know this concept. So children, till now we have discussed about P subshell. P subshell can accommodate 3 6 electrons. P subshell has 3 orbitals and it can accommodate 6 electrons. A D subshell which has 5 orbitals can accommodate 10 electrons. Now coming to the next subshell, which is the F subshell. Children, F subshell is made up of 7 orbitals. F subshell has 7 orbitals. So what is your answer? F subshell is made up of 7 orbitals. So I think you must be able to predict the number of electrons which can be accommodated in the F subshell. F subshell can accommodate, F subshell can accommodate 14 electrons. So I hope this point is clear to you, children. According to Pauli's exclusion principle, no 2 electron in an atom can have all the 4 quantum numbers equal. So after that, after discussing this, how many electrons can be accommodated in SP, D and F subshell, I want to come to a very important conclusion. Children, already in my previous videos, I have explained you that number of orbitals for a shell, number of orbitals for a shell which belong to principal quantum number n, which belong to principal quantum number n are equal to n square. In a very simple way, I want to explain you. By using this formula n square, we can calculate number of orbitals in a shell. For example, for first shell, what is the value of n? For first shell, n is equal to 1. So what will be n square? N square will be equal to 1. It means first shell has only 1 orbital. First shell has only 1 orbital. And you know what is that orbital? That orbital is 1s. Similarly, so what I was discussing quickly, I want to revise it, that number of orbitals we can calculate for a shell which belong to a principal quantum number n. So for first shell, the value of n is equal to 1. N square is also 1. It means first shell consists of only 1 orbital, which is named as 1s. Now, I just want to discuss about the second shell. Second shell, n is equal to 2. For second shell, n is equal to 2. So how many orbitals will be there for the second shell? The number of orbitals for second shell will be equal to 2 squared. That will be equal to 4. So children, second shell consists of 4 orbitals. And finally, we are coming to a formula. The formula is that number of electrons which can be accommodated in a shell. Just now I told you that for a shell whose principal quantum number is n, number of orbitals are equal to n square. So how many electrons can be accommodated? As each orbital can accommodate 2 electrons. So number of electrons which can be accommodated in a shell will be equal to 2 into n square. This you can explain. For example, first shell. How many electrons first shell can accommodate? First shell can accommodate only 2 electrons, 2 into 1 square. Second shell can accommodate 2 into 2 square, 8 electrons. Third shell can accommodate 2 into 3 squares, means 18 electrons. So I hope these points are clear to you, children. Thank you so much for watching my video. Please subscribe my channel and like this video and share this video with your friends also. Don't forget to watch my next video. Have a nice day.